For problem number 15, we're trying to find the domain and the range of all 6 of the trig functions without using your notes. So you can either memorize these or you can think your way through them, but I'm going to write them down here for you. So we'll do it like this. We'll make a little chart. So we'll say, okay, the function, its domain, and its range. And what I'll do is I'll walk you through each function and kind of how I rationalize this. So let's start out with the sine function. So sine measures the height value of a point on the unit circle. And if you think about all the different angles, the input for the sine function is an angle. In fact, for all of these functions, the input is an angle, whereas the output is a real number. When I say real number, I just mean, pretty much any number you can think of that doesn't, that's not in the complex. I shouldn't even say that's not in the complex plane, but that doesn't have a complex or an imaginary component. So what about the domain here? Well, sine, the input, you can input any angle you would like. There's no problems. The functions don't explode if you input like 90 degrees or something like that. So we're going to say from negative infinity to infinity is the domain. In fact, the same thing for the cosine function. It has all possible angles can be plugged in. What about the range? Well, sine, the output, the things that can come out of sine. So if you think about sine as like the function is like a box. Okay, an angle, we'll call it theta, goes in. What comes out? Well, if you think about the way the unit circle works, the only height values that you can get out are between negative 1 and 1. So numbers between negative 1 and 1. Including negative 1 and 1, because we can get positive 1 up here, negative 1 down here. So this is going to be between negative 1 and 1. So this is how we write that interval. Cosine measures left-right. So the furthest right we can go is positive 1, the furthest left we can go is negative 1, and we can get every other number in between. Tangent. Whoops. Okay, we can plug in every angle except the following. We know that tangent's not defined at 90 degrees, and it's also not defined at 270 degrees, or any other angle that's coterminal with those angles. So now watch. If I go to 90 degrees, okay, we can use everything. So I'm going to say it like this. I'm going to say all angles, or all numbers, except the following. Theta cannot be equal to 90 degrees plus 270, which is 90 degrees plus 180, plus another 180, plus another 180, plus another 180. So we're going to write it as 180k, where k is an integer. Now what's the output values? Well, remember, tangent is like if we put a tangent line out here, like this, and so it's this distance. So tangent can give us any value we want out, any height value we want. So that's going to be from negative infinity to infinity. Okay, now let's look at there's the 3 reciprocal trig functions. So sine goes to cosecant. So since cosecant is a reciprocal of sine, or sine is the reciprocal of cosecant, okay, then cosecant, which I'm going to put it underneath, is 1 over sine. Now, cosecant will be defined everywhere except we can't plug in values where sine is equal to 0. So when is the height 0? Let's redraw this over here. The height's 0 at 0 degrees and at multiples of 180. So 180, 360, so on and so forth. So we're going to say all numbers except angles. The angles can't be equal to 180 degrees times k, where k is an integer. Now what values come out? So this is not as easy. Okay, so the values that come out of this guy are 1 over sine. Now the sine values that can come out are between -1 and 1. So they're going to be, essentially they're going to be decimals, right, between -1 and 1. If we divide 1 by a decimal that's between -1 and 1, we're going to get a value out that's more than 1. So we're going to say this. We can get out all negative values up to and including -1. And then we can get from 1 out to infinity. Being able to see this guy right here is easier with a graph. Okay, but we're not in a position right now to graph it. So you're going to have to either just remember this or go through it logically as far as why it would be the way it is. Secant is 1 over cosine. Now I'm not putting an argument there, which is the variable or theta, okay? So I'm just trying to write it as an idea, so this is not mathematically correct. So this is going to be all numbers for the domain. We can plug in any number we want, except we can't plug in angles where cosine is 0. And cosine is 0 at 90 degrees. Okay, cosine 0 down here at 270 degrees. So basically 90 plus 100 half revolutions, multiples of half revolutions, so 180k. K is an integer. The numbers we can get out are the same thing as the cosecant. So negative infinity to -1 union 1 to infinity. The last one is the cotangent. Now cotangent, since tangent is sine over cosine, cotangent is cosine over sine. So cotangent can use any number as an input, any angle. So we say all numbers except it can't be when sine is 0. So cotangent and cosecant are going to have the same domain. Cotangent can get any number out. Okay, so that's not going to be a problem. And there's all of your domains and ranges for your 6 trig functions.